And next we have Brandon Pitts. He's a assistant professor from industrial engineering, and he's going to talk about assisted driving.
Oh, where's the clicker? It's under the shirt. Sorry. Okay. Let me make sure I can make this work. Okay, great. Hello, everyone. My name is Brandon Pitts, as she just said, and I have been here less than 2 years now. So come January 2019 would be my second year. And I'm coming from industrial engineering. I am the director of this lab here. It's called Enhance. And actually, Dr. Rogers was an inspiration for that because I didn't want it to be associated primarily with age. I didn't want age in the name. I wanted it to be a little bit more than that. I wanted to communicate to people that we're trying to enhance the quality of life, improve, advance, so on and so forth. But you can see here that the main concern that we have, or the area that we're really operating in, is focusing on the older adult in complex work and transportation environments. I'll leave Dr. Rogers to the home and the social robots and those kind of things. We're thinking about complex environments where people are interacting with complex technologies, complex environments. There's a lot of information. People are working throughout later stages of life, so on and so forth. So that's kind of where our space is. Some people may say, why? When we think about people getting older, it's not just that they're getting older, but they're driving longer and they're working longer. And they're not just working longer, for example, at Walmart or sitting in front of a desk. Some of them are working in manufacturing. And us being here in the Midwest, you look at Caterpillar, they are hiring and still continue to employ people who are up in age. And so we really have to think about how automated technology, how are they going to interact with those kind of things. So that's where we're coming from. This is my lab group. We just took this picture about a week ago. And so this is just a fancy tool that we have that I'll talk about in a second. All right. So how are we contributing to age and technology? We work in 4 specific areas. One of them is called context-sensitive display design, where we look at multimodal displays. So how do you communicate to people using visual, auditory, and tactile information? We look at adaptive displays where systems are intelligent enough to understand performance, how a person is performing. If they're performing poorly, I can assess that through eye tracking, through performance metrics, and then I can adjust the information content in response to that. Speech recognition, some of what you heard earlier today. We're also operating in the space of autonomous systems. That's what I'm going to end the presentation with. We're talking with older adults about how do they perceive and rate their driving abilities as they get older, and what implications does that have for them accepting certain aspects of technology, and also does that lead to them trusting automation and ultimately using it. So Dr. Rogers mentioned that there is this potential that technology can help, right? And this is a list of 16 different in-vehicle technologies that have the potential to help older adults. And there's still a lot of work that needs to be done. And I bring this up because they are in a variety of formats. Some of them actually just present an alert to a human. So for example, there's a lane departure warning signal. I'm driving down the highway, I cross the lane boundary, and the vehicle gives me a signal. Well, there are some systems, for example, like automatic braking. If a ball runs out in front of me or the vehicle detects something, it can actually brake for me. So these technologies are on a wide scale, from just from just alerting to assistive. And so they tend to be in multimodal form. We can present these alerts visually. We can do it through the sense of touch. We can do it through hearing. And one of the things that we had thought about is that the more you introduce information, the more you introduce these systems to the vehicle, the higher the chance that multiple signals, multiple warning alerts can go off at the exact same time. And so we realized that was a question that was not being answered in the literature. And so we came up with an experiment where we wanted to say, what happens if an older adult is faced with a situation where they're presented with a light, a sound, and a vibration at the same time, and each of those signals refers to 3 separate events, okay? So in this example, I'm gonna say the vision is a notification from the GPS system. I'm gonna say that the auditory is a lane departure warning, and I'm gonna say that tactile or vibration is collision warning. So if I get all three of those at once, how do I behave? And so that's kind of the experiment here. These were kind of the factors. We did vary age, of course, so we had a group of younger adults, two groups of older adults, and there was a factor called occupation, some who were working, some who were retired, and we were trying to figure out if continued cognitive demand affected a person's ability to detect multimodal cues, okay? You can kind of see some other factors there. So this is the graph that I really like to show because it shows exactly what happened when we give them all three signals. So the task was that they were driving down the highway and they could get any combination of signals. So at some point we gave them visual, auditory, and tactile signal. At some point we gave it to them in combination, so a light and a sound, or a vibration and a sound. And then in one case we gave all three at the same time. And so we did that because we needed a baseline. And so, not surprisingly, what you can see is that when they get all three, the older adults were the ones who had the most trouble identifying what was going on. So, anybody has a guess for what might have happened? You give someone a visual, auditory, and tactile signals. What do you think happens? Give up. They give up. Do you think they can detect any of them? No? Okay. So, I'll tell you, believe it or not, it was that they missed the vibration, okay? They reported the light, they reported the sound, it was the vibration that was dropped, and this was even after we had performed a task called cross-modal matching, where you allow people to adjust the perceived intensities of these signals so where that's not a confounding factor, okay? So they missed the vibration in that case. What do you think happened when you give them a sound and a vibration? Why do you think that detection rate was low? Okay, so you think that what would that lead them to do?
If there's a sound and a vibration, maybe they don't hear the vibration.
Okay. All right, it was actually something more surprising than that. They actually falsely reported that a light was present, okay? And so some people may say, well, which one of these situations is more dangerous? To me, both of them are dangerous. So if I'm presented with three signals and I miss one, and it's alarming me about something, then I'm in trouble. But on the other hand, if I think that I see something and I respond to it, then I'm in trouble. So just implications for design. If I look at what happened with their driving behavior, we can see this was not affected by age, but across all of our age groups, we see that when it was a statistical difference, we do see where after people were presented with all three signals, they tended to change their speed somehow. We couldn't find a pattern whether they slowed down or sped up, but it did happen. And so that's implications for design. I want to end with this idea of vehicle automation. Sometimes people call it self-driving vehicles. Sometimes they call it driverless vehicles. And some people think that it's binary, that either a vehicle is autonomous or it's not autonomous. And that's not how this actually works. There is something called levels of automation, where there are actually 6 levels. 0 means that the human is in full control. 5 means that the automation is in full control, and then 2 to 4 is everything, or 1 to 4 is everything in between there. So level 1, that means you have one automated system like an adaptive cruise control or a lane keeping assist. Level 2 means that you've got at least 2 of those systems activated, so a lane keeping and a cruise control. Level 3 means that you're activating 2 or more systems, but now the vehicle can handle more dynamics. So now I can start and stop, and I can turn corners, those kind of things, but the expectation is that the human is still fully engaged. Level 4 automation is essentially full, but in certain conditions, a person is expected to be able to take over at some point. And then level 5 is actually, and some people are talking about if we ever get there, that's where there is a driver, but there's no steering wheel and there's no foot pedals. So I just want to end by saying that there's a lot more work that's needed in this area. We have someone, actually Dustin here, who's recruiting for an experiment that he has going on. We'll be doing the exact same thing, but there's very little empirical data on how older adults will interact with autonomous vehicles at all of those levels that I mentioned. So some research questions, for example, is if I'm expected to take over, what does that look like? And there are several reasons why a person may be required to take over. Maybe the vehicle has reached its design limit, or maybe it fails. Okay, and so the vehicle needs to communicate to me either through visual, auditory, or tactile signals. How do I take over? When do I take over? What does that look like? And so we want to focus on the takeover time, but also that post-takeover behavior. You saw that when people were given the light, the sound, and the vibration, they tended to change their speed. Well, does that have any implications for this autonomous driving? If we ask someone to take over, the vehicle is traveling at 70 miles an hour. Are they going to keep the same speed? Are they going to slow down? Are they going to speed up? Those kind of things. And those are the things that I'm hoping that my lab over the next few years will be able to address. And I think I'm out of time, but that's all that I wanted to talk about. So, I don't have time for questions, sorry. I don't get off that easily, right?
Thank you, Brandon, and the floor is open for questions.
Yes.
Hey, Brandon, thanks, that was super interesting. Thanks, Brandon, that was really interesting. I have a question. I can see from what you presented, like why you say this area is so needing of empirical research of older adults in general and how they're going to interact with the autonomous vehicle. And I wondered also about two different situations with the idea that vehicles could, like if there's a medical crisis, for example, and the older adult is the driver, or is in that situation, kind of what's being done around that. And also just the ability of the vehicle to kind of monitor health function. So we had this situation in my own family. My father-in-law came home from the hospital. He was on oxygen. And his physician said, basically, I think it's a big effort for you to get to your car, and I'm going to sign off on you getting your driver's license back if you agree to sit, I forget if it was 10 or 15 minutes, and let your oxygen level come back up to where it should. But the car at that point was not measuring it. This was like a human, fully negotiated process, and then he got his license back, which there were some issues around that. But anyway, there was no way for the car, like the same way you would have a blood pressure monitor or something. I was like, is there any effort to sort of see whether vehicles can also evaluate the health component of the driver as well as maybe their cognitive function?
Yep. So
Other parts of the health?
So there are these car companies are certainly working on that kind of technology. So some of them, for example, have eye tracking capabilities where they're able to detect if the eyelids are closing, and they can give you a notification saying that the person is falling asleep. And they're not just looking at eye tracking, but it's eye tracking in combination with their driving performance. So looking at those two things, it says, person is falling asleep, I want to send some alert, or I want to take over. The same has been doing for heart rate monitoring. Sometimes that's a little bit more intrusive because you're asking someone to wear sensors. But one thing, we have a project where we're actually trying to develop a nano sensor, where a very small sensor that you can put on the wrist, and it can detect changes in heart rate. You can sync that with the vehicle. The vehicle is monitoring all the time. And then there are some cases where I can actually send that message with these connected vehicles. I can send information about my health status to a nearby hospital. And that is, I don't know if you have anything you wanted to add to that, but that is the idea of telehealth. And so, yeah, we're moving in that direction. Those are the two that I'm familiar with, and I'm sure there'll be some more development.
Because I guess just to finish up, like, it seems like the form of the signal would matter there. Okay? So that's what I'm learning from your presentation, like whether that's going to then be a visual alarm or an auditory
I see.
Like, hello, what's
Absolutely.
going on here, and how they're going to perceive that.
Yeah.
On alcohol or drugs?
Yeah, so there's work being done on that as well. Interventions I'm not sure about, but there are certainly systems that can detect, and a lot of it is based on driving performance if you're under the influence. I saw a hand somewhere over here. Okay.
Hi, Brandon. Thank you for this really interesting presentation. I think this is very important. And one of the human factors I thought of as you were presenting was sleep and the influence of sleep and how well you sleep on cognition and how that interfaces with driving. And I was wondering if that's something you've thought of measuring or have measured, and your thoughts on that.
Okay. We have not done anything with sleep just yet. There is some potential for that, because when you talk about a person needing to take over control of the vehicle, there are a lot of people who are varying certain things. So one of them is am I fully engaged? Am I monitoring? So what's my takeover time like? Then there are other cases where if I'm eating or I'm reading a book or I'm engaged in a conversation and I'm not looking at the forward roadway, what's going to be my takeover time? How early do I need to inform the person, so on and so forth? And then there is another category where people are thinking about, let's say the drive is 2 hours, you fall asleep, and there's something comes up, I still need to alert the person, right? But I need to wake them up, and we all have our recovery times for how long it takes us to kind of come back. And so that is certainly some potential in the future. We just have not explored the area, but I know that there's work being done about that. Okay.
Time for one more question. Would you be able to implement some of the sensor technology into some of the current like equipment in the car, like the seat and the driving handle, and like maybe the stick shift or something, instead of having something invasive like a wearable tech?
So the reason people tend to go for wearables is because it's always on the body. Whereas so I can do it to the steering wheel, absolutely. But if I do it to the gear shift, the shift gear, then the expectation is that the person is always holding on to that. So if I release it and then there's a signal that needs to be communicated and I'm not touching it, I don't get it. So that's why they sometimes use the seat pan. You can put vibrations in the seat. The person is always touching that. Same thing with the steering wheel. You would hope that they're always touching that. And so, yeah, I don't know. That's the best I think I have. So, all right. Thank you.